Hello everyone, this is our set of the day. It says 10 friends A, B, C, D, E, F, G, H, I, J. They decided to attend the state fair at ABC Stadium, and after attending the cultural program, they decided to play some games, and they bought some tickets from number 1 to 10, and they managed to get the tickets having the numbers equivalent to the number of their initials. That means A had the ticket number 1, B had the ticket number 2, and so on. Now for the game, all of them kept their tickets on the table in such a way that ticket numbers were not visible and the tickets were shuffled. Then each one of them picked the ticket randomly, and when they showed the ticket numbers, it was found that the ticket number of the ticket picked by each friend from the table was maximum one away from its initial purchase ticket number. For example, if we talk about C, so C has purchased C's number initially was 3. C's initial number was 3, so C's final number could be either 1 less 2 or 1 more 4, or it can also be 3 also, right? So now we have these questions with us. Let us try to solve them one by one. Now first says, if D got to pick his initial ticket again from the table, that is ticket number 4, then maximum how many friends could not be having the same ticket as their initial purchase ticket, right? So initially, if I talk about the initial ones, so initially they have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 tickets. Now D has taken 4 tickets, right? This is the initial arrangement. Now for final, it says that D still has 4 tickets. Now what can happen before D? There are 3 people before D. So what can happen? Either A and B can exchange their tickets, or B and C can exchange their tickets, right? A and C cannot exchange, because if A and C can exchange, then the number will increase by 2. It says it can be maximum 1 point away. So A and C cannot exchange their tickets. So either it could be 1 and 3 2, or it could be 1 2 and 3. That means, sorry, 1 and BC are exchanging 3 2, or AB can exchange, so 2 and 1, and this will be 3. So that means from the first 3 friends, one of them will definitely have his own initial ticket. In the first case, A is that person. In the second case, C is that person, right? So at max, 2 people can be there in these among these 3 friends. In the first 3 friends, there could be at max 2 people who can exchange their tickets, right? They cannot be all the 3. One of them will definitely have his or her initial ticket. So there are only 2 possibilities from here. Now after that D, we have 6 friends. So it is very much possible that E and F, they are exchanging their tickets. G and H, they are exchanging their tickets. I and J, they are exchanging their tickets. That means all of them are exchanging their tickets. So 6 people are there. 6 and 2, 8. So at max, there could be 8 persons who did not have the initial tickets with them. Right? And question is also asking for the maximum. How many friends could not be having the same ticket? So maximum would be 8. Right? D is not having his initial ticket, and one among A or C will definitely not have the initial ticket. Answer would be 8. Now in this question, it says that in how many ways can they take their tickets such that exactly 4 students were not having the same tickets as their initially purchased ticket, right? Exactly 4 students were not having the same ticket. Now let us make some assumptions here. Let us see that if someone has his initial ticket, if someone has his initial ticket, then let us mark him as 1. Let mark him 1. If someone does not have initial ticket, then mark him 2. Mark him 2. Okay. It simply means, why mark him 2? Because there would be 2 people who are exchanging their tickets. So if I just write down this number, let's say 2, 1, 1, 2, 1, 1, 1, 1. Right? Now their total should be 10 because there are 10 people. It means since the order is 2, 1, 1, 2, 1, 1, 1, it means this 2 is corresponding to A and B. That means A and B, they are exchanging their tickets. C and D, they have their original tickets. E and F, they are exchanging their tickets. G, H, I, J, they have their initial tickets. I hope this is clear to everyone because this makes this question easy. This method will make this question easy. Right? The total would be 10 always. If I write 2, 2, 2, 2, 2, 2, let's say 5 times, it means A and B, they have exchanged. Obviously, A and C cannot exchange because then difference will be more than 1. So when they are exchanging, they should be the consecutive ones also. They cannot be A and C or A and D. Here it is C and D who are exchanging. Here E and F are exchanging. Here G and H are exchanging. Here I and J are exchanging. If I write like this, 2, 2, 1, 2, 2, 1, it means A and B are exchanging. C and D are exchanging. E has initial ticket. F and G are exchanging. H and I are exchanging, and J has his initial ticket. I hope this is clear to everyone now. Now this makes the question easier. The total, remember, is always 10. 2 plus 2, 4 plus 1, 5 plus 2, 7 plus 3, 10. Here we have 5 times 2, 10. So that total will remain 10 because we have 10 people. So 2 simply represents 2 friends. 1 represents only one friend who does not exchange the ticket or who has the initial ticket. Now it says, in how many ways can they take their tickets such that exactly 4 students were not having the same ticket? That means 4 people, they have exchanged their tickets. So when they are exchanging the tickets, let's say A, B, C, D are exchanging the tickets. So A will exchange with B, C will exchange with D. So I will take this as 2. I will take this as 2. So it would be, the arrangement would be 2, 2, 4. Then I will have 6 times 1. Now it could be A, B, C, D. It could be A, B. It could also be like this: 2, 1, 2. It could also be like this: 2, 2, 2, 1, 1, 1, 1, 1, 1, 2. Right? 6 times 1 is here, or it could be 1, 1, 1, 2, 2, 1, 1, 1. So basically what happens is I have 2 2s, 6 1s to arrange. That can be done in 8 factorial divided by 6 factorial into 2 factorial ways. 8 factorial into 6 factorial into 2 factorial ways, which is 8 into 7 by 2 or 28. That means in 28 ways uh, they can exchange the tickets such that exactly 4 are not having the tickets as their initially purchased tickets. Now for the next one, it says if the number of ways in which exactly n students not having their initial tickets is maximum possible, then what is the value of n? What is the value of n? Now let us say that, first of all, just understand the question. It says the number of ways in which exactly n students not having their initial tickets is maximum possible. So number of ways should be maximum. N students are not having the initial tickets. So we need to find the value of n. Although you can solve this question by options, but otherwise, let's say if one pair exchange the tickets, if one pair exchanged, That means the order would be 2 and 1 1 1 1 1 1 1. One more is there, right? So 8 times 1 and 1 2. It can be done in how many ways? There are total 9 arrangements. 9 factorial divided by 8 factorial, since we are having 8 times 1, right? So this is 9 cases. Basically this can also be written as 9C1. The number of times you are taking 2, that can also be that can also give you the same answer, 9C1. 9C1 is also 9 factorial by 8 factorial. Here value is 9. If 2 pairs exchanged, then that means we need to get 2 2's in any order. I'm just writing like this: 2 plus 2 4, 5 6 7 8 9 10. So we are having 3 plus 3 6 plus 2 8. We have having 8 elements here, in which 6 ones are there, 2 2's are there, right? So it can be written as 8 factorial upon 2 factorial, because these 2 2's are repeating, these 6 6's are repeating, 6 factorial, or this is also 8C2, which is 28. Similarly, if 3 pairs are exchanging, then it would be 7C3, 9C1, 8C2, next it would be 7C3, which is 35. If 4 pairs are exchanging, it would be 6C4, which is 15. If 5 pairs are exchanging, 5 pairs means all of them are exchanging, it will be 5C5, which is one way. All the 10 people are exchanging, right? So how many? So I think this is an only possible ways. The question says the number of ways in which exactly n students not having their initial tickets is maximum possible. Now among these values, the maximum possible ways are 35. That happens when 3 pairs are exchanging their tickets. So when 3 pairs exchange the tickets, in 3 pairs there would be 6 students. So it means 6 students are not having their initial tickets. And in that case, we have the maximum value for the total number of days. Answer would be option 2, 6. Then the value of n is 6. In the next one, it says, what is the total number of ways such that at least one of the student is not having his initial ticket again? Number of ways. At least one of the student is not having the initial ticket again. That means either one pair has exchanged, or 2 pairs has exchanged, or 3, 4, or all the 5 pairs have exchanged the tickets, and they are already written on the screen. If only one pair has exchanged, then total ways would be 9. If 2 have exchanged, then it is 28. For 3 it is 35, 15 and 1. So total number of ways is asking, so answer would be the sum of all these values, 9 plus 28 plus 35 plus 15 plus 1. So if you add up this comes out to be 88. Answer would be option 3. I hope this is clear to everyone.